Bonjour les amis, last tutorial of 2025, and today I wanted to show you a quick but effective workflow around Niagara system. And why not creating snow, for example? Because yeah, this is the typical season, right? Crispy tips around how to set up Niagara system, event handler on collision, like how to spawn decals and other particles around one source emitter. Plenty of tips, it's Christmas, so let's dive in. First of all, take a look at this beautiful and cozy little scene from the Eat Happy seller on Fab. I randomly stumbled upon it and it immediately gave me this idea. Why not show a quick but effective snow Niagara system with a few crisp tips you can reuse across all your projects? So let's jump right in. First, let's create our Niagara system using a simple fountain emitter. The first thing we want to fix is this visible starting point when particles spawn. A very simple way to handle this is by tweaking the scale color module. Here we'll add a key to the curve and adjust the alpha of the sprite. The horizontal axis represents the particle's lifetime, normalized from 0 to 1, while the vertical axis controls the sprite's opacity, where 0 is invisible and 1 is fully visible. This is all driven through the vertex color node in the sprite material. By adding a key in the middle and putting the initial value closer to it, we smoothly fade in the particles and hide the spawning starts. Simple, clean, and effective, no need for complex setups. Next, let's tweak a few more parameters. We will increase the overall spread using the shape location module, and then adjust the spawn rate to give the snow a richer, more lively feel. The best way to fine-tune all of this is, of course, to place the system directly in the level and adjust it in context. This is where a really powerful workflow comes in: user parameters. For any value you want to adjust live, or even drive later via blueprints or sequencer, you can expose it as a user parameter. Let's take the spawn rate as an example. Using this icon, switch it to a user parameter. Once it's set, the value is no longer edited directly in the module, but exposed in the user parameters panel. And if you go back to the level, you'll see that this value is now available directly in the Niagara system instance details. The same applies to blueprints and sequencer. This makes your system incredibly flexible and reusable. Let's do the same for the shape location radius, so we can easily adjust the snow coverage directly in the scene. Let's add a bit of curl noise to break the motion and make it feel less straight and repetitive. Just a subtle amount already adds a lot of natural variation. And that's perfect. After that, we can also tweak the color in the initializers particle module. By pushing higher values on the V channel, we're effectively increasing the emissive contribution, which helps the snow read better, especially in darker environments. Alright, now let's go a bit deeper. This is already a great start, but there's one issue. The particles are currently passing straight through our meshes. So how do we handle collision? And more interestingly, how can we trigger an effect when each particle hits the ground? This is where collision and event handlers come into play. Adding basic collision is actually very simple. In the particle update section, just add a collision module. Right away, with the default values, you will start seeing results. To better visualize what's happening directly inside Niagara, you can enable the floor from the preview settings in the editor. You can spend a lot of time fine-tuning this module. For example, you can use ray trace collision for more precision, at a higher performance cost, or use planes for something cheaper but less accurate. But there are two key parameters that really make this feel like snow. First, the restitution value. Lower it close to 0 to avoid bouncy particles when they hit the ground. A value closer to 1 will behave more like a rubber ball, which is definitely not what we want here. Second, kill on collision. Setting this to something like 2 means the particle will be destroyed after 2 collisions. This helps avoid visible bouncing even with a low restitution value. These two parameters alone already go a long way in selling the effect. Of course, you can keep tweaking the rest to match the exact look you're after. For demonstration purposes, I will exaggerate the values a bit so it's easier to see what's going on. But you can refine everything later in your own projects, of course. Now for the fun parts. Reacting to collisions. What we want is to capture information when a particle hits the ground and use that data to trigger another effect, like spawning a decal to simulate snow impacts on the surface. The same workflow can be reused for rain, dust, sparks, and many other effects. The idea is to read data from a parent emitter and reuse it in another emitter within the same Niagara system. And from here, the possibilities really open up. In the particle update section, let's add generate collision event. You can drop it in without changing anything. It works perfectly out of the box. The only thing Unreal asks us to do is to enable persistent IDs. This parameter is mandatory, as it allows Unreal to properly read and reuse data from this emitter in other emitters. Now that the parent emitter is fully set up, let's create a new one for a ground splash effect. We can start from a minimal emitter, which is more than enough for this purpose. For now, let's keep the sprite renderer. We will replace it with a decal renderer later. To read data coming from the parent emitter, we first need to create a new section using the plus stage button. In this new stage, add an event handler. Inside it, make sure to select the correct source, which in our case is the fountain emitter using the collision event. Then change the execution mode to spawn particles and set the spawn number to 1. Otherwise, nothing will spawn. Now that the source is defined, we can read and apply its data by adding another module in the same section, receive collision event. And just like that, this emitter now reacts directly to the collision events from the source emitter. Every time a particle hits the ground, this emitter updates accordingly. Pretty cool, right? Let's make it look better by switching to a decal renderer. We can remove the sprite renderer and add a decal renderer instead. For that, we'll need a decal material. Remember, a decal is simply a material projected onto surfaces in the world. Here I created a simple but effective material using a radial contrast exponential plugged into the emissive color. Make sure the material is set to default decal as the material domain with a translucent blend mode, otherwise it won't work. You can expose parameters like radius and density to fine-tune the look. As shown here, you can also drive the color through a vector parameter. Back in the Niagara system, we can now assign this material to the decal renderer. Almost there. We still need to adjust the lifetime and size of the decalled particles. The lifetime is set in the initialize particle module. Let's set it to 1 second. For the size, add a decal attributes module. Inside the size section, enable apply, which allows us to actually override the values. Lower the size a bit to keep everything subtle and believable. Et voila! We now have a fully working decal emitter that reacts to each collision of our snow particles, creating nice and believable snow impacts on the ground. But we're not done yet. What if we want to add another collision event, this time to spawn secondary snow splash particles when the main particle hits the ground, on top of the decals? Say no more, let me show you, mes amis. Now let's create one more emitter, again starting from a minimal emitter. Just like before, we'll add a new section using the plus stage button and choose an event handler. Set the source to our main fountain emitter using the collision events. Define the execution mode as spawn particle, and this time let's spawn 2 sprites on impact to make the effect more visible. You can push this higher if you want a stronger splash. Don't forget to add receive collision events in the same section, otherwise the emitter won't read the collision data. To give these splash particles a bit more presence, we can add a shape location module and slightly increase the radius, so they spread a bit on impact. Finally, we'll add collision again using the same idea as before. Lower the restitution to avoid bouncing, and tweak kill on collision so the particles don't hang around for too long. Add a bit of color, adjust the size if needed, and we're good to go. And that's it guys, a simple, clean and effective snow system you can reuse in any project. From emitter tuning to collision to event handlers, everything you need is right there. Hope you enjoyed it. Thanks for watching this video guys, this is the last one for 2025, let's give it a break and meet again on January 6th of 2026. A new year full of videos, tutorials, and awesome content. Just for you. I'm preparing some heavy stuff for you guys. Let's meet next year. Enjoy the break and Merry Christmas. Ciao.